So today we are going to talk about computer programming on binary numeral system. Let's start with a story. There are 10 kinds of people in the world. One can understand binary numeral system and one cannot. What does this joke mean? You will be able to understand this by the end of this class. Binary numeral system can be dated back 2,000 years ago, started from ancient Egypt. They have the weird pattern named the Eye of Horus. Each part of his eye represents a fraction in the base of 2, like 1/2, 1/4, and 1/8. Ancient Egypt used these fractions to represent the weight of grains and liquids. This is a pattern of Taiji, 两仪, 四象, and 八卦, started from Taiji, which represent everything, and one in China. And then we have 两仪, which is yin and yang. We can take yang as 1 and yin as 0. It can derive into 四象, which means 4. So we have 1, 2, 4. And here we have 8, which is 八卦. So this is an example of the binary numeral system from 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Why use binary numeral system in computer programs? Because it is easy and convenient. For the binary numeral system, it only has 2 states, which is 0 and 1. And for electricity, we have 2 states, which is on and off. Matches 0 and 1 in binary numeral system. So it is most efficient for a computer to read and process this information. So how to convert from decimal numeral system, which is the numeral system we are using today, to the binary numeral system. First, we need to separate this number to 2 parts, which is the integer part and the decimal part. We take the integer part divided by 2, take the remainder as the result, and divide the quotient by 2 again until we get 0. Like 12, we divide it by 2, we get 6, the remainder is 0. We get 3, the remainder is 0. Then we divide it by 2, we get 1. The remainder is 1. We use 1 divided by 2, which is 0. And then we get the remainder is 1. So we arrange all this result in a reverse sequence. We get 12 in binary numeral system is 1100. Then we move the decimal place. And for 0.25, we times it by 2, take the integer part as a result, and use the decimal part times by 2 again until we get 0 or 1. First, we times 0.25 by 2. We get 0.5, and the integer part is 0. Then we times 0.5 again by 2, we get 1, and the integer part is 1. And we arrange it in the right sequence, which is 1100.01. And this is how to convert from decimal numeral system to binary numeral system. How to convert from binary numeral system to decimal numeral system, which is pretty easy because we take the digit on the left from the decimal place, where each digit represents 2 to the power of n minus 1. So the first is 2 to the power of 0 and is 2 to the power of 1. The third is 2 to the power of 2, so on and so forth. On the right of the decimal place, we get 2 to the power of negative 1, 2 to the power of negative 2, negative 3, so on and so forth. So we use each number in the digit times the number it represents and we add them together. So we get 0 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 3, which equals 12. For the decimal place side, we use 0 times 2 to the power of negative 1 plus 1 times 2 to the power of negative 2 equals 1 over 4. We add them together is 12.25, which equals our original number. So this is my computer programming on the binary adding, and let's first do the compiling thing, see whether this program has any grammar issues. Okay, it passed the compile now. Let's try a few numbers. First, we get we have 100.01 as 12.25 for our answer, and then let's add it to 10, which is 2 in our decimal numeral system. Then we get 1110.01. As we know that 0.01 is 0.25 in our decimal number system, and 1110 we can calculate as 8 plus 4 plus 2, which is 14. So 14.25, it is 12.25, add 2. In the end of presentation, I have 4 problems for you, and if you can get them all right, you can get several extra credit, depends on Mr. Chen's mood. And thank you, bye.